In this video we have integral number 7, which is a trigonometric integral involving powers of sine and cosine. If you want to give this a try, go ahead and pause the video and I'll be right back. Okay, this is what I'm going to do. I'm going to let u equal the sine of x. And the reason I'm doing that is because I got a net power of cosine. So I know I can take one power, put it together with the dx, and then the derivative sign is cosine. And then here I'm going to have cosine to the fourth. I can rewrite that as cosine squared squared. Replace the cosine squared by the expression involving sine. And I'm going to multiply by sine. So I'm going to have all the u's. Everything in terms of u there. In other words, it looks this way. Du, derivative sine is cosine of x dx. So here's what I'm talking about. This will equal to, okay, sine squared. Well, that's going to be u squared from the substitution. So I want to get all sines involved here. So this is going to be cosine squared x, and then that's to the fourth power. Because what I'm doing here is I'm breaking the cosine to the fifth into cosine squared and cosine. So I'm putting my cosine over here, dx, and this should be a 2 here. So here we have it. By substitution, it's u equals sine of x, and then du equal cosine x dx. So this right here can be replaced over here by du. The sine, of course, is u, so I got that. Then this is u squared. And then remember that cosine squared of x plus sine squared of x is equal to 1. So this cosine squared right here, if I bring this over to this side, cosine squared will be 1 minus sine squared. 1 minus sine squared x. So right here, cosine squared x is 1 minus sine squared x. But remember, sine is u, so this can be replaced right here by 1 minus u squared. And then that's squared. And then we said cosine x dx, that can be replaced by du. So always when you have these type of problems involving trigonometric integrals, look ahead. If you got odd powers, you can break it up like this and get everything in terms of what you let u be. That's what you need, because then you're just integrating everything in terms of u. So this is going to be equal to, then you got u squared here, and then we square the 1 minus u squared. That'll be 1 minus 2u squared plus, and then the u squared is u to the fourth, and I got the du. And we continue with the simplification, multiply through by u squared. So this will be u squared times 1 is u squared minus 2. And then u squared times the next term is u minus 2u to the fourth. U squared times the u to the fourth is u to the sixth. And then that's du. Now it's just like integrating what it is. You're integrating now a regular polynomial. Easiest type to integrate. So just using the power rule for integrals. So add 1 to the 2 and divide. So this will be u to the third divided by 3. Next one, add 1 to the 4, you get 5. Divide the coefficient by that, I get minus 2/5. Plus, add 1 to the 6, it would be u to the 7. Divide by 7, and then your constant of integration, c. And then we're pretty much finished, other than going back to the original variable. So we know that u is equal to sine of x. So just next step, wherever you have a u, put sine of x. So this will be sine to the third x over 3. Next one, minus 2/5 sine to the 5th x. Plus the next one. Again, all we're doing is replacing the u by sine of x. And we get sine to the 7th x of x there over 7 plus the constant of integration. So we get sine to the third of x over 3 minus 2/5 sine to the 5th of x plus sine to the 7th of x over 7 plus the constant of integration. That's your answer. Thanks for watching. See you next time.